So welcome to the finite element methods. So today we're going to see that what would be the procedure for solving a problem by using the finite element method. The procedure is same for the different types of elements. So means that the for a bar element, and if you take beam element, and if you take truss element, and two-dimensional element, constant CST or axisymmetric elements. So whatever the element would be. So, but the process would be the same. Our process will be the same. Means that the execution steps are common for all types of elements. So the elements is nothing but whenever you done the discretization. So in the process of discretization, we are going to be used that different types of elements that will be depending upon the nature of the problem. But whatever the nature of the problem, but the procedure will be the common. So here, now we're going to see that the procedure. The first one would be the, you should identify the given problem. Whether the given problem is beam problem or the bar problem or the truss or any two-dimensional element problem. Because in our curriculum, the unit number 1 to 5, that is dealing with the first units are dealing with the bars, and second units are trusses and beams, and third unit would be the, it is a CST element and axisymmetric elements. And also in the fourth unit, we are talking about the heat transfer analysis. In the fifth unit, we are going to see the dynamic analysis. In all those units, the procedure will be the common. So now the first one is you have to be identify the given problem, whether the given problem is related to the heat transfer, or it may be the dynamic analysis, or it may be the structural analysis. If it is structural analysis, you should use that appropriate element for the for solving the given problem. So the first and foremost step is you need to be identify the given problem. The next one would be the very important one. It is define that the discretization or discretize the given problem into a number of small elements, or we can divide into a number of elements. That is called discretization. So discretization is nothing but you are going to be dividing the big problem into a number of small problem. The next one would be the, you need to take the interpolation function. You have to be assume that interpolation function, and from that interpolation function, you have to be find the element stiffness matrix. So the next step is you should use the interpolation function to define the stiffness matrix for each and every element. So the fourth step is you have to find the each and every element stiffness matrix. So once you know the each and every element stiffness matrix, you have to club all the individual element stiffness matrix to get the global stiffness matrix. Means that the fifth step is assemble the all individual element stiffness matrix to get the global stiffness matrix. So once you know the global stiffness matrix, then you need to concentrate on the how to write the global displacement matrix and global force vector. So at this point of time, if you know the global stiffness matrix, global displacement matrix, and global force vector, then you need to be focused to write down the governing equation for a given problem. So this governing equation will be different for the different application of the problem. So that will be going to deal with the whenever you have a problem, that time we will going to define the governing equation. So the seventh step is you should write down the governing equation once you know the global stiffness, global displacement, and global force vector. So after writing the governing equation, the very important step is you have to be identify the boundary conditions for a given problem. For a given problem, there would be some boundary conditions that you have to be identified, and you need to be apply the boundary condition in a governing equation to reduce the complexity of the equation. So the governing equation may be that it is a complex equation. To reduce that the complexity, you have to be apply the boundary condition, and you need to be use the elimination process that will going to be discussed elaborately in the next classes. Then after applying the boundary condition, you have to be solve the system of equation for unknown values. So in a global equation, there would be some unknowns will be present. To solve that unknown values, then you have to be used to solve the system of equation, and then you'll be able to get that the nodal displacements are nodal temperature, etc. So after getting that, the nodal parameters, that is called displacements, and you should focus on the how to calculate the strain for a simple elements. Okay, so you should find out the strains. Then after finding the strain by using the Hooke's law, you have to be calculate the stresses also. So these are the very important steps that will be common for all type of analysis. Thank you.